And so we grow in our understanding. Welcome to another tutorial. I'm your host Fraser. So right now we're in our finite automata, and now we're gonna convert and finish here and start something called transition graphs. Okay. Transition graphs takes remember how in my previous tutorials I was only inputting one input in my state machine, so I'd input one over here, one, and then zero over there, zero over there. Now we're gonna start something called transition graphs, which are machines that allow um, edges or equivalently to be reading more than one number of inputs at a time. We shall now leave the definition of a finite automation alone and call these new machines called transition graphs, which are more easily understood graphs as than tables. A transition graph is basically a graph that can be abbreviated by TG and is a collection of three things: a finite state of at least one of which is designated the start, and one obviously your end. So you have your initial and then end, okay? And then from there you have an alphabet or possible input values, which can be like, for instance, I've inputted more than one this time, so I'm using binary digits, so zeros and ones. Those are my preferred input values because it's easier to understand from which input strings are formed. And then a transition graph also consists of a finite set of transitions that show you how to go from one state to another based on reading the specified substrings of input numbers, possibly even the null string. So we haven't talked that much about the null string, abbreviated by the Greek alphabet of delta, if I'm correct. No, we abbreviate the null string with the Greek lambda symbol. So lambda is like an upside down triangle. So in front of us we have like a nice simple that takes in multiple inputs instead of singular. Singular, for instance, here's 0, and this is multiple 2, and then this is 3. So this one takes 3 inputs to start, this one takes 2 inputs, and this one takes 1. So if you simulate it and run through the steps, you'll see 0 and 1 go over here, and 0 and 1 and 0 end up in this state, which is my final state, my Q3. What happens if I have just an odd number of inputs? So it should end up in Q2. So Q2, but look here, remember how my input is 3, so the machine reads as 3 inputs and stops here. It doesn't proceed here because the final input would have been 0, but it doesn't go further, so they both stop at the same place. And then for instance, if I step with inputs that are not valid, for instance 111, it doesn't go because I only want a certain input, and it doesn't qualify for any of the states of my transition graphs. Therefore it does not move. And then since I have an input of a larger values, right, from my input file, text file. So I just have different types of inputs to check which ones qualify for my final state and which ones do not. So it's gonna say accept or reject if they do qualify for my state. So I'll run this, and as you can see, only the qualified results move on. And yeah, you can your start and final ABC states, and you can even convert your inputs into like an easy regular expressions that is accepted by all my graphs. And I'll see you in my next tutorial. Thank you for watching.